Okay, let's do one thing. So the moment I'll release the system, then the weight M1G will act. These are the various forces we know. Then the tension in the string, the tension T in the string. And then any other forces, the weight of the wedge, normal contact. Then there's a normal contact between the block and the wedge. Here also, if you want to show it the 2T, I think already you know we have analyzed what forces acting on the pulley that is acting on the wedge also. So this will be only T. Yeah, you make it like this. No, which forces are doing what? Suddenly so many things came, no? And now how the motion of the block? It will have displacement, the wedge will have displacement x2. The block will have displacement x1. And the block will have displacement y1. What are all this x1, y1? Displacement of block. Any constant equation, x1 must be equal to x2. Any relation between y1 and x2. x1, y1 should be equal to x2. So therefore, with this, we'll also get relation between the velocities, no? The speed of the blocks. I'll take the one more diagram. Here I'll show only velocities. How the velocity of the wedge will be like this, v2x, velocity of the block. And what about the v1y? Got it? So now from the constraint equation, what you can write it here? From the constraint equation, what you can write? v1x equal to v2x, then v1y equal to 2v2x. Got this? So this is the constraint equation. Okay, now can you apply conservation of mechanical energy? So we should identify all the things now. What is work done by normal contact? 0, because the wedge will not move vertically. Work done by the weight M2G will be 0. Let's come for work done by normal contact. N1. Work done by N1. N1 does positive work on the block, no? So here we write N1 into X. And it does negative work on the wedge. And we know from constraint equation X1 equal to X2. So therefore, what is the net work done by the normal contact acting between the block and the wedge? Will be 0. Got it? No. Similarly, come for the tension. Work done by tension. Net work done by tension. Tension does negative work on the block M1, no? So minus T into Y1. Then what about the tension? Tension is acting at 2 points here as well as here. 2T into X2. I'm just showing the method to solve. You can apply this for almost all the wedge constraint problems. So look at the constraint equation y1 equal to x2. This will be 0. Okay, see now. Finally, what happened? Tension does positive work or negative work on the wedge. It does positive work. Say I'm telling this on this chapter. If you want, I'll teach for whole 1 year. The whole 1 year we can discuss. Just because any numerical you can bring it and you can say work done. It's an unlimited topic, that one. Got it, no? So work done by tension on the wedge, positive work. It does positive work. Work done by tension on the block, negative work. Net work done by tension, 0. Able to get this? I'm just writing mathematically everything I just concluded here. What about normal contact? It does positive work on the block M1. It does negative work on the wedge. Tension does negative work on the block M1. It does positive work on the block M2. Net work done by tension 0. Normal contact N1 does positive work on the block M1. It does negative work on the block M. How you can say sir negative? Look at X2 and N1 opposite, no? So negative work. N1 and X1 same direction, so positive work. So tell me, like, what is the only force doing work? The weight M1G. Can you apply conservation of mechanical energy? Yes, it is. So what is the, now we'll enter into the thing now. Decrease in potential of block M1, decrease in potential of block M1 equal to increase in kinetic energy of block and wedge. So what is the decrease in potential energy? M1GH. That's what we took, no? That should be equal to what? M1 V1Y square plus M1 V1X square plus M2 V2X square. But all three are unknown, no? What to do? Take help of constant equation.
Sir, what about potential energy of wedge, sir?
Potential energy of wedge. Are you not seeing wedge will move vertically down? Wedge will move vertically down, will go underground. Nothing, no? Will be there only. Potential in the wedge remain constant. Okay, substitute all the values. So here you use constant equation, you get the required answer. I think what is the requirement of the problem? It's not that just writing some equation. What we have to do? We have to really put effort in drilling these things. Unless we don't conclude this part, no, it's not advisable to write any equation. So we should give maximum priority for these ideas. This is not multiplied, it is somewhere some information. Don't take again, I'm multiplying the bracket one there. Y1 equal to 2x2.